We're going to continue in this section by talking about streams, and we're going to talk about not only how to create streams, but also how they're used with the classic map, filter, reduce mechanism, and look at some examples of that. So starting right off the bat here is a class that I've called Streams Demo, and I start off with a list of strings as an attribute. So I have an array list which creates this is a list of strings as a list, and now I'm going to do something with them. Now, first of all, this join stream method isn't using that array list, not directly. Instead, it's using the of method to produce a new stream. I want to show there are multiple ways to produce streams, and this is one of them. I'm going to come back to that array list a little bit in a method a little bit further down. The of method is what we call a factory method. It's a static method in the class that is used to produce an instance of that class. And in the Java 8 API, they have used that of approach on many different classes as a factory method for creating it. So this returns an instance of stream. Now, what the collect method then does is the collect method converts a stream into a collection. Now the collect method can get fairly complicated, but fortunately there's an overload that takes one of these things. This is called a collector, and in this case there is a class called collectors that has a factory method called joining that will return a collector of character sequence, etc. So the idea here is that collectors.joining will take a stream and convert it into a single string with the delimiter specified as the joining argument as your overall delimiter. Now in this case, I also have a test class for this one. And in the test class, you can see that after instantiating the streams demo, I can invoke join stream, and this is what I should get out of it, and that does in fact work. I'll run all the tests just to prove a point. In fact, let me just run them all right now. And then when you see that they all pass, then I don't have to run them all individually. We could take a look at the implementations. So invoking join stream takes a stream of strings and joins them into a single string with a delimiter. This is known as a reduction operation. It produces a single value from a stream. There are more general reduce methods. There's actually a method called reduce, but this one is built in as a simple way to produce the single string. Now, the next method here is called join uppercase, and now we're back to that array list. In this case, I'm invoking the stream method on collection here. If I look at the details, then we see that this is a method that has been added to the collection interface as a default method so that it doesn't break any existing collections, but the idea is that it will return a sequential stream over all the elements of the collection. So it returns a sequential stream over all the elements in the collection, and that's the idea here. So once I've done that, now I'm going to invoke a map method. Now map is interesting. Map says take the current stream and produce a new one by applying the function argument to every element in the stream without modifying the original. So we're doing real functional programming here in the sense that we're not modifying anything, we're producing new ones instead. So we are using a method reference here to invoke the toUppercase method in the string class. The toUppercase method in the string class converts a string to uppercase, obviously, and what the map method will therefore do is convert our stream into a new stream where all the strings have been made uppercase, and once again I'll join them with the space as a delimiter, and you can see in the test case that the result is pretty much what you would expect. Calling join uppercase gives us this is a list of strings as a single string, all uppercase. In this version, get total length, again I produce a stream and I invoke collect, but I'm using a different static method in the collectors class. This time it's called summing int. Now what summing int says is convert all the elements of a stream into an integer, and then it will add them up for you automatically. So I'm using the method reference for string length. String : length is as though I had put in the lambda s arrow s dot length. This way, I will replace in the new stream all the strings with their corresponding lengths, and then summing int will add them all up. Once again, in the test case, you could see the summation happening right here. Now, let's do a totally different approach to creating a stream. This is the iterate method. The iterate method in stream takes an initial value and then a producer. The idea behind a producer is that it creates a new value as we go. Now, if I look at the syntax for this, this is actually taking an argument of type unary operator, which is a subclass of function. Actually, we can see that here. If I go to my java.util.function package and scroll down to unary operator is a subclass of function of one argument which produces a value of the same type. So in other words, this is a unary operator, takes a type and produces the same type as a result. And we can see if we looked at the method, it's called identity, but that's not really our issue here. It's simply a way to take a value and return the same value transformed in some way. In this case, what I'm doing is I'm starting off with 1 here. Now, what does 1 mean? This is, in fact, big integer 1, but I have, or pardon me, big decimal 1, but I've already imported the big decimal class using the static import. I've done a static import of big decimal 1 so that this is short for that. And then my unary operator says take a value and return value.add 1 to that. With big decimals, we can't use our plus operator. We just invoke the add method on that. So this starts off at 1 and then produces the next value by adding 1 to it. Now that, of course, would produce an infinite stream. That could go on forever. We didn't actually say how many. The limit method then specifies how many we want max. So it says limit it to whatever number we put in here, however many the number is, that's how many we want. Once I have a stream of that many numbers, I can then map them to double by invoking the double value method and then summing them up. Now, why convert them to doubles in order to sum them? Because the stream method itself does not have a sum method on it, or the stream interface doesn't have a sum method, but double stream does. So yeah, I may be giving up a little bit of precision here, but at least I can add them up easily this way. So the name of this method is sum the first n big decimals. And if I take a look at that in the test class, I can say assert that the sum of the first n big decimals 10. So I'm looking at the first 10 big decimals is close to 1 plus 2 plus 3 all the way up to 10 within 0.01. It's actually, the precision's a lot better than that, I would think. I could probably go to 0001 here. And once again, just to prove that the tests all pass, yep, they're all still fine. I'm using the Ham-Crest matchers for is and close to with my precision there. So that's an easy one as well. So we saw stream as a method. We saw of as a method on stream to produce a stream, and we saw iterate as a method to produce a stream. The final mechanism for producing a stream that I want to show is the generate method. Generate method takes as an argument a supplier. So the supplier produces values with no arguments, and in this case I'm using the random method in the math class. So there's another method reference, this time accessing a static method in the math class. Once again, this would be an infinite stream. We would produce as many values as we asked for. We're limiting it to a certain number. Then we're calling the reduce method, interestingly enough, by calling double : sum, and that returns something special called an optional. Now, an optional is the new mechanism in Java 8 to try to handle things that could potentially be null. So rather than returning a value that could be null, we return an optional that's wrapped around the value. And then we can invoke a method like if present to see if there's a value there, or get to retrieve the value. And that doesn't really sound like we've gained much, because then it's the same as checking to see if there was a null there in the first place. So what we have as an alternative, and this is a really nice convenience method, is that optional has an or else method. And what or else will do is it will return the value out of the optional if there is one there, or else it'll return some default inside there. Now there's also a variation called or else get, which would take a lambda as an argument, and if there's a value in the optional, it'll return it. Otherwise, it'll produce one using the lambda inside the or else get method. So this one I'm saying either produce the value, the sum here, or just give me back 0 in all of this. This is the same mechanism with the full form of the reduce method. Again, we're talking map, filter, reduce here. I'm not doing any filtering yet. I'll show an example of that in a minute. So I'm generating a series of random numbers, limiting it to the number that I specify, and using a reduce method, which takes 2 arguments and a lambda, or a block here. And the idea is that this first argument is whatever is returned out of the block on the previous iteration, and the second argument is each number in the stream. So what I'm doing here is I'm saying return the accumulator plus n, and that will be the next value of the accumulator on each iteration. In fact, I'm printing them out not because I needed to, but because that makes it easier to see what's going on. And you can see here that when I'm running this particular one, there's the first value of the accumulator was the first random number. And here, let me put it on some randoms too. And you can see this is the first random number after that, and then this is the sum of those two, and then there's the next random number, and this is the sum of the accumulator plus that one, and there's the next random number, and so on and so on. So you could actually see the accumulation happen that way. Finally, here is the doubles method inside of random. The java.util.random class has been enhanced to have a method called doubles, which produces now a stream of doubles. In fact, called a double stream. Then I can limit it to a certain number, and again, on double stream, I have a sum method directly. So this is a whole series of mechanisms for producing streams and then using them. Another thing I could do is I could use that person class. Remember the person class I did in the database chapter? I have a person that has, let me illustrate what I'm talking about here. Here's the person class, has an integer ID and a string name, and the rest are just getters and setters and toString and equals and hash code, etc. So I made an array list of names, and I've got various names in there that may look vaguely familiar if you're a Game of Thrones person. I said names.stream to produce the stream, and now I'm going to map each name into a new person with that name. That's using the person constructor and then returning a list. So this will actually produce a list of people. And that's fine for producing a list. What if I want to produce an array of people, a person? Well, first of all, my IDE here is complaining to say, you know, this could be replaced with a method reference. I'll show you that down here, and then I'll do the additional conversion. If you want to invoke a constructor, you can write the lambda, or you can use the method reference with the word new on it. So person : new will invoke the constructor for each element of the stream, which is composed of strings. So this will produce a new stream full of person objects. And then I can invoke the toArray method, which requires an array of persons. And notice that I could do new on person array as well. And the result produces an array of person objects, whereas the previous one produced a list of person objects. To show that I can replace this lambda with a method reference, here it is in this case. I can go .stream and then map it to new. And this is the full form of collect. Rather than using collectors.toList, the full form of collect takes 3 arguments: a way to create the collection, a way to add a single item to the collection, and a way to add multiple items to the collection. And in this case, I know exactly what methods are required in ArrayList for all 3 of those operations. So I can use method references for new, add, and add all, and thereby do the same thing. Now, of course, it's much easier to just do collectors.toList, but this is the full form, and if there's something that you don't have a to method for, this is the mechanism used for the big picture. So down here, I'm going to go instantiate this class I'm going to create the person list in the first mechanism, create the person list using new here, create the person array, and when I create the person array, I'll iterate over and printing out each one individually. See, the reason I'm doing that is that there's a nice toString method on list, which will work for these two, but there's no good toString method on arrays, so instead I'm going to loop over the array this way. And you see there are my toString methods being invoked on list, and this is invoking the toString method on each individual person as I loop over them. The IDs are all null because, as you may recall, those IDs were set when the entity was stored in the database, and I'm not storing them in the database, so I'm leaving them at null at this point. So there's another mechanism that allows you to work with all these different pieces. I want to look at another interesting situation, and that is sorting. Now, in this sorting demo, I want to sort strings. Now, we looked at sorting strings earlier when we were talking about inner classes, and I did an anonymous inner class to sort by length, and I mentioned that you could simplify that with lambdas. Well, we're in the lambda section now. I thought I would show that in detail. So here is my list of sample strings, and this was the alphabetical sort that's used in Java 7 and below. You do collections.sort, which will do a destructive sort and then return it. Here is a reverse length sort using a comparator with the implementation of the comparator. And yet here I replace the comparator with a lambda. You can see that this lambda pretty much matches, well, exactly matches the signature of the compare method along with the body as well. So this is a forward sort, ascending order. The other one was a descending order mechanism, but the method signatures are the same. And finally, I can take this one and actually convert it to its full verbose form in case you still want to see everything. This way, putting in parentheses, I could see the data types. I have braces now. Notice I didn't need a return keyword when there was only one line. Now I can put in the return keyword as well. I can use integer.compare rather than subtracting. In other words, this is the same thing as the one above it, but in its most verbose fashion. Now, there's another mechanism, rather than do this for comparisons. If I know I'm comparing ints, then there's actually a comparing int method in comparator that says convert everything into an integer, and then I'll compare the ints, and once the ints are compared, I'll sort the collection based on that. So this sorts the ints, representing the lengths, and then sorts the collection as a result. And then this gets even better. Let's say let's compare the lengths in ascending order and then comparing the equal length strings using their natural order, which would mean alphabetical. So the result of that is that I get all the strings in ascending order by length and then equal length strings sorted alphabetically. And that all works very nicely. Now, all of this was done inside the sort method, which, remember, is the destructive one. Fortunately, in Stream, there's now a method called sorted, which produces a new stream that's already sorted. And this is the one that does the natural sort, the alphabetical one. But sorted has an overload that takes a lambda to do my length sort. But I can also do dot sorted with comparator.comparing length, then comparing natural order. And this is probably the one I would ultimately use to sort everything. And I have a test case that also tests all of these individual ones as well. The last one I want to look at the moment, and then I'll show a couple other interesting features, is using a map and a filter and a reduce. It turns out that on every Unix system, and Macs qualify there, the OS X or OS X is a Unix flavor, there is a dictionary on the disk under the path user share dict web2. This is using the paths class to set up this path, and then the files class has a lines method that produces a stream from this path with one per line. So every line in that file is now an element of the stream. So it reads each line in the file and produces a stream of those lines. In the user dictionary, each word is on its own line. So this is basically a stream of the words in the dictionary. So once I have that, now I want to do a filter. Now the filter method takes a predicate. That's got to return a Boolean for things that pass the filter. So I'm going to say for each string such that its length is greater than 10. Those are the only ones I want to pass the filter. Once I have the ones that are greater than 10, I'm going to map them to lowercase, and then I'm going to sort them using the sorted method based on length reversed, so that I'm really trying to look at the longest to shortest strings, but I'm only interested in the ones that are length 10 or above. I limit it to the top 10 of those. So they're length 10, but I only want the top 10. And then for each of those, I'm going to print them. Now, I could have done the method reference on print line, except that that wouldn't allow me to put in a formatted string. So I want to put in the formatted string here. Now, I'll comment out the rest for the moment, and then I'll run this and show you what the result is. And the result shows me that the longest words in my user dictionary start with formaldehyde sulfoxylate and then go to pathologico-psychological and so on. So those all have 24 characters, and then I have a series with 23 characters, and then it would go on from there. So this is doing a filter and then a map, and then it's not exactly a reduce. I sorted them, and I said I only want 10. In this case, my terminating expression is to simply print them all out. Now, in the next one, the one I commented out, let me uncomment that now. What I've done is, again, read the lines out of that user dictionary and filter them by length greater than 10, map them to lowercase, do the sorting, but this time I only want the first one, and the first one can be acquired by using the find first method. Now, the find first method returns an optional. Now, I could have done an or else after this directly, but just to illustrate how you work with an optional, here I took that max, which is an optional type string, and say if it is present, call get, or else put in none found. But honestly, I could also just do or else get with a lambda, or what I'd really do in practice is just say or else, because what or else will do is it will return a value if it's there and return nothing if it's not there. So if I run this example after my top 10 strings, then I'm going to be printing out 3 times that first one that was found as part of the collection. So there's a quick illustration of optional as well. Now, I have a couple other pieces I'd like to show you in terms of laziness and in terms of concurrency, and those I'll cover in the next section. But this section hopefully gives you a sense of how to generate streams, how to map them to using some new functions, how to filter them, and then how to reduce them or do some other terminating expression. Java 8, as you can see, has a very rich set of classes and methods for this sort of processing that go well beyond what we've talked about here. Hopefully, though, this will give you a good sense of what is available.